Welcome to our next session. All right, in this session we are going to see some previous year question that is asked from the type of reaction. All right, so let's start with our first question. All right, that is asked in 2022, a 3-marker question. All right, write one chemical equation for each of the following reaction. One, they are asking change in color, change in temperature, formation of precipitate. All right, and mention the change temperature change, rise and fall of the compound precipitated along with the equation. All right. So first we will start with our first one, change in color. All right. So a very popular equation. All right, that is AgCl silver chloride, all right, whose original color is white, which decomposes in the presence of sunlight to produce silver plus Cl2 gas. All right. So its color changes from white to gray color. All right. Now we should balance the equation. So here we have 2 atoms of chlorine and here we have only 1 atom. So what we will do, we will make the coefficient, stoichiometric coefficient as 2. Here we have 2 atoms of silver, so we will add 2 over here as well. All right. So this is our first question, change in color. Silver chloride, that is white in color, changes to gray during the thermal decomposition with the sunlight. All right. We will move to our next question, that is change in temperature. All right. We all know when we take calcium oxide and reacts it with water, it's an exothermic reaction. So we get calcium hydroxide plus heat is generated. All right. So we will write the physical state of all the reactants and the product. All right. Now see this is the change in temperature, means temperature will rise during the reaction. All right. Now is it balanced? Let us check. So we have 1 atom of calcium, 1 atom of calcium, 2 atoms of oxygen, 2 atoms of oxygen over here, and we have 2 atoms of hydrogen, 2 atoms of hydrogen. So it is balanced. So done question number 2. Let's start with question number 3, formation of precipitate. All right. So if we take sodium sulfate plus barium chloride, both are in aqueous form, what do they form? They form barium sulfate, that is a precipitate, plus Na2SO4 BaCl2 BaSO4 plus salt NaCl in aqueous form. All right. So check when sodium sulfate reacts with barium chloride, barium sulfate and salt is formed in aqueous form. All right. So this is a formation of precipitate. This barium sulfate is precipitate. Precipitate. All right. So let's move to our next question. Let's take our second question. All right. Aluminium metal react with steam to give aluminium oxide and hydrogen gas. All right. So we'll try to write the equation. aluminum solid that reacts with water, that is steam, is in the steam state, that is gas, to give Al2O3 plus hydrogen gas is released. All right. Now we have to balance it. So we have 2 atoms of aluminum over here on the product side and only 1 atom on the reactant side. So you can put the coefficient as 2. Now our aluminum is balanced. All right. Now see, there are 2 atoms of hydrogen over here, 2 atoms of hydrogen. There is only 1 atom of oxygen and there is 3 atoms of oxygen. So what we will do, we will make here 3 atoms of oxygen. All right, that makes 3 to the 6 atoms of hydrogen. So what we will do, we will take this coefficient over hydrogen coefficient as 3. All right. Now our equation is balanced, we can check it. 2 atoms of aluminum, 3 to the 6 atoms of hydrogen, 3 atoms of oxygen. All right, balanced. All right. So this is our balanced equation. Aluminum metal react with steam to give aluminum oxide and hydrogen gas. All right. So we will move to our next question. Okay. So our next question, all right, tells us that it is a 2-mark question. No precipitation reaction can occur without exchange of ion between 2 reactants. Justify this statement giving a balanced chemical equation for the reaction. All right. So we will take one precipitation reaction. All right. First, what we will take? We will take BaCl2 in aqueous form plus H2SO4 that gives us BaSO4, that is our precipitate, plus HCl, that is in aqueous form. All right. Now this is our precipitate reaction. All right. This is H2SO4 is also in aqueous form. All right. Now what we have to do? We have to balance it and we have to justify that this precipitation reaction cannot happen without the exchange of ion. All right. Now why it can't happen without the exchange of ion? Now when we mix BaCl2, all right, it is going to dissociate as Ba2 plus ion plus 2 Cl minus. All right. And H2SO4 is going to dissociate in its ionic form H plus plus SO4 2 minus. All right. So when we mix barium chloride and H2SO4, first what happens? Ionization of BaCl2, BaCl2 dissociate as Ba2 plus Cl minus, and H2SO4 dissociate as 2H plus SO4 2 minus. All right. So now what will happen? This Ba will combine with SO4 to make BaSO4. All right. And this H will combine with chlorine to make HCl. All right. So what is happening over here? Exchange of ions between the 2 reactant. All right. So no precipitation reaction can happen without the exchange of ion between the 2 reactants. All right. Let's move on to our next question. Alright. So our next question is a 2-mark question. Give one example of each to differentiate between a displacement reaction and a double displacement reaction. Alright. So one reaction will take of both displacement and double displacement reaction. Alright. We will take first displacement, and second is double displacement. Alright. So in displacement we can take one reaction as Zn when reacts with CuSO4 in aqueous condition, that gives ZnSO4 aqueous plus Cu copper solid. Alright. And double displacement reaction we can take sodium sulfate aqueous plus BaCl2 aqueous mix BaSO4 plus NaCl. Alright. Okay. So this is one example of displacement reaction. This is one example of double displacement reaction. Now what happens in displacement reaction? Only one element, alright, displaces the other element which is higher in reactivity series. Now what happens in double displacement reaction? Alright, both cations and anions both are exchanged in the reaction. For example, this sodium and sulfate and this barium and chloride, alright, one is cation, sodium is cation, sulfate is anion. So both are exchanged in the reaction, and in displacement reaction only one displacement takes place between whichever is the highest in reactivity series. So Zn will replace copper because zinc is more reactive than copper to make zinc sulfate, and copper will be deposited as solid. Alright. Let's move to our next question. All right. So they're asking, this is a 1-mark question asked in 2024. When aqueous solution of barium chloride and sodium sulfate reacts together, an insoluble substance along with aqueous solution of sodium chloride is formed. This reaction is an example of. So just now we have seen this reaction is the example of double displacement reaction. All right. Let's move on to our next question. All right. Now this is a 3-mark question. All right. Write a chemical equation for the reaction in which change in color is observed when a metal is kept immersed in a salt solution of another metal. All right. So we'll do the part 1 first. All right. Now what we have to take? We have to take a metal immersed in salt solution of other metal. All right. So suppose if we take iron, as a solid and CuSO4 copper sulfate in aqueous form, that will give us FeSO4 plus Cu. Alright. Now, what is the original color of this copper sulfate? This is blue in color. Alright. Now, when iron displaces copper in the solution, alright, the solution color changed to green color. Alright. And this copper is deposited whose color is reddish brown. Reddish brown. Alright. So, this is one reaction of a metal in the salt solution of another metal, and change in color is blue to green, and copper will be deposited as a reddish brown color. Alright. Let's take our second question. When hydrogen gas is passed over copper 2 oxide, copper and steam are formed. Write the balanced chemical equation with the physical state for this reaction. What kind of chemical reaction is this? Okay. So, let's take our next question. Alright. When hydrogen gas is passed over copper 2 oxide, so we will take copper 2 oxide, CuO plus hydrogen gas, that will give us copper solid plus H2O gas in the presence of heat. Alright. Now, the original color of copper 2 oxide, that is black in color. Alright. And when it reacts with hydrogen gas, it converts to brown. Brown in color. Alright. Now, is it balanced? 1 copper, 1 copper, 1 oxygen, 1 oxygen, 2 hydrogen, 2 hydrogen. So, the equation is balanced. Now, let's move on to our next question. Alright. So, we will start our next question, question number 7, that is a 1 mark question asked in 2024. Alright. Which of the following example of endothermic reaction? What is endothermic reaction? The reaction in which heat is absorbed during the reaction. Alright. So, digestion of food in a human body is a exothermic reaction because energy is produced. Formation of slaked lime is also a exothermic reaction because heat is produced. Decomposition of vegetable matter into compost, that is also a exothermic reaction. So, what is our correct option? Decomposition of silver bromide into silver and bromine. Now, what is the reaction? So, AgBr in presence of light decomposes to silver plus bromine gas. Alright. So, we will balance this equation. Alright. So, which is our correct option? Decomposition of silver bromide, that requires light to decompose to silver and bromine. So, this is our endothermic process. Alright. Let us move on to our next question. Our next question is, when magnesium ribbon is burnt in the air, the ash of white color is produced. Write the chemical reaction for the reactant giving the chemical name of the ash product. State the type of chemical reaction giving and justify your answer. Alright. So, when magnesium ribbon is burnt, so let us write the reaction first. Alright. So, magnesium ribbon that is Mg solid, and combines with oxygen in the presence of heat gives MgO solid, that is your ash. This ash produces your MgO, magnesium oxide. Alright. Now let us balance the equation. Alright. So there are two atoms of oxygen, there is only one atom. So we will make the coefficient as 2, and there are two atoms of magnesium, there is one atom. So we will make it 2 over here. Now our equation is balanced. Now what kind of equation is this? What is the type of equation? They are asking type of chemical reaction. Alright. So see, there are two reactants which is combining to give a one single product. So what kind of reaction this is? This is combination reaction. Alright. Okay, let's move on to our next question. Okay, so the study they have this is a question asked in 2024, a 3-marker question. Study the experimental setup shown in the figure diagram. This is the diagram, alright, and write the chemical equation for this diagram and define the type of reaction. List 2 other metal which can be used in place of iron to show the same type of reaction with copper sulfate solution. So as you can see in the diagram, copper sulfate solution and iron nail is dipped into it. Alright. So we will try to write the reaction. So we have iron as solid form that is dipped into copper sulfate CuSO4, that is in aqueous form. So when iron reacts with copper sulfate, it produces FeSO4 plus copper solid. Alright. So CuSO4 is blue in color and FeSO4 green in color. Alright. Now what kind of reaction is this? See, iron is displacing copper from its solution. Alright. So what kind of reaction this is? This is a displacement reaction. Displacement reaction. Alright. Now they are asking list 2 other metal which can be used in the place of iron to show same type of reaction with copper sulfate solution. Alright. So if you know the reactivity series, alright, you can easily answer this question. Alright. So whichever metal is present above copper in reactivity series, alright, we can take any 2 metals. Alright. So for example, zinc, and magnesium both are above copper in reactivity series. Alright. So both can replace copper from its solution. Alright. So this is our answer. Let's move on to our next question. Alright. Now this is a 3-mark question asked in 2023. Alright. This is a repeatedly asked question. Alright. Electrolysis of water. Name the gas liberated at anode and cathode. Alright. Why is it that the volume of gas collected at one electrode is 2 times on the other electrode? What would happen if dilute H2SO4 is not added to the water? Alright. So let's solve this question. Alright. So what happens in electrolysis of water? H2O in the presence of electricity decomposes to 2H2 gas plus O2 gas. Alright. Now they are asking name the gases liberated at anode and cathode. Alright. So what gas will be liberated at anode? Oxygen. And what gas will be liberated at cathode? Hydrogen. Alright. Now why is that volume of gas collected at one electrode is 2 times the other electrode? Alright. Now look over here. Hydrogen is 2 times of oxygen. There are 2 moles of hydrogen and only 1 mole of oxygen. Alright. So that's why you will get twice the hydrogen than oxygen. Alright. Now what would happen if dilute H2SO4 is not added to water? Alright. Now what is this function of dilute H2SO4? This dilute H2SO4, alright. Now in electrolytic reaction, what happens? We need a strong electrolyte to complete the reaction, but water is a weak electrolyte, alright. So we add dilute H2SO4 to facilitate the electrolysis process, alright, to make the electrolytic process more efficient. So if you don't add H2SO4 into the water, what will happen? The reaction will be very slow. Alright. So this is the reason we add dilute H2SO4 in the electrolyte. Okay. So next let's move on to our next question. Alright. So our next, before moving to our next question, alright, that is redox reaction, oxidation reaction and reduction reaction. Let us revise once what is oxidation and what is reduction. Alright. So gain of oxygen is oxidation. So oxidation reaction are identified by few of the criteria. Alright. First one of them is gain of oxygen, that is oxidation, or loss of hydrogen, or loss of electron, or increase in oxidation number. Alright. What is reduction? Reduction is loss of oxygen, gain of hydrogen, gain of electrons, or decrease in oxidation number. Alright. So we will solve few questions, alright, to get us familiar with the concept of oxidation and reduction. Alright. So this is question 1, alright, that is asked in 2024. Select the correct statement from the following about the reaction. So we have a reaction given, copper oxide reacts with hydrogen to give copper and H2O. Alright. So what you have to do, you have to find the correct statement. So first statement is copper oxide is getting oxidized and H2 is getting reduced. Now second statement, H2 is getting reduced. We will check one option at a time. Alright. So our first option, alright, CuO. CO is getting oxidized and H2 is getting reduced. Alright. So what was oxidation reduction? See over here, Cu is losing oxygen. Alright. If you look over here, copper oxide is losing oxygen. Alright. Now what is this loss of oxygen called? See over here, loss of oxygen. Loss of oxygen is reduction. Alright. So is it getting oxidized? No. So this statement is wrong. H2 is getting oxidized and CO is getting reduced. Alright. So H2 is gaining oxygen and Cu is losing oxygen. Alright. So this option is correct. Option number B. H2 is getting oxidized and Cu is getting reduced. Alright. Hydrogen is gaining oxygen and copper is losing oxygen. Alright. So let's move on to our next question. All right. So this is a session reason based question. All right. Hydrogen gas is not evolved when zinc react with nitric acid. Nitric acid oxidizes the hydrogen gas produced to form water and itself get reduced. All right. Now we know that whenever metal reacts with any acid, hydrogen gas is produced. All right. But in the case of nitric acid is a strong oxidizing agent. So what happens? Nitric acid oxidizes the hydrogen atom to water. All right. So hydrogen gas is not liberated during this reaction. All right. So our assertion is also correct. Our assertion is also correct, and nitric acid oxidize hydrogen gas to produce water and itself get reduced. That is also correct. So which option is correct? Both options are correct, and reason is the correct explanation for the assertion. All right. Let's move on to our next question. All right. For this question, we can see the reaction as well. All right. So if we take Zn solid plus HNO3 in aqueous form, that gives us Zn NO3 twice in aqueous form plus H2O plus NO2 gas is released. So as you can see by the reaction, all right, HNO3, that is nitric acid, oxidize the hydrogen gas produced to water. All right, that's why hydrogen gas is not released in this reaction. All right, let's move on to our next question. All right, so they're asking identify the reducing agent. This is a 4-marker question. All right, asked in 2024. All right, identify the reducing agent in the following reaction. All right, now how do we identify the reducing agent? All right, just now we have seen. Okay, how do we identify which one is reducing agent? The compound which is being oxidized, all right, that will be the reducing agent, and the substance which is being reduced, that will be oxidizing agent. All right. So as you can see over here, 4NH3, 5O2 and 4NO. All right. Now see over here, NH3 is losing hydrogen. All right. So which one is the reducing agent over here? NH3 is losing hydrogen. All right. Nitrogen is losing hydrogen or gaining oxygen. So our NH3 is our reducing agent. The substance which is getting oxidized, that will be reducing agent. All right. Next is our Fe2O3. All right. Now observe here, carbon monoxide. All right. It is gaining oxygen. So if any substance is gaining oxygen, that is being oxidized. So if it is getting oxidized, that will be reducing agent. So what is reducing agent over here? Carbon monoxide. Alright. Coming to our third equation. Alright. So observe over here, our hydrogen is gaining oxygen. Alright. So hydrogen is getting oxidized. So hydrogen is reducing over here, reducing agent over here. Alright. Coming to the second part, they are asking define a redox reaction in the terms of gain or loss of oxygen. Alright. So just now we have seen how do we define a redox reaction in terms of gain or loss of oxygen. So gain of oxygen is known as oxidation and loss of oxygen is known as reduction. Is reduction. Alright. So this question completed. Alright. So oxidation reduction based question is very frequently asked. Alright. So certainly they will ask either to identify the reducing agent or the oxidizing agent. Alright. So the substance which is getting oxidized, that is reducing agent, and the substance which is getting reduced, that is oxidizing agent. Alright. Let's move on to our next question. This is the answer. You can see how to write your answer. Alright. You can take a screenshot. Okay, so coming to our last question, that is the application of oxidation and reduction, asked in 2022 of 2-mark question. Alright. Now what happens when food material containing fat and oil are left for a very long time? List 2 observation changes, suggest 3 ways by which this phenomena can be prevented. Alright. So in your day to day life also you have observed, when you keep any oily and fatty food for a very long time, alright, they become rancid. Alright. So what happens, their taste changes. So we have change we have 2 effects. First is our change in taste and second is change in smell. Alright, they become rancid. Alright, this process is known as rancidity. Alright. Now what are the preventive measures that we can take? Alright. So as you can observe in your day to day life, alright, what preventive measures we take to store oily and fatty food for a little bit longer time. Alright. So what do? We put it in a very airtight container. Alright. So our first preventive measure, put it in airtight container. Our second option, what do to store our oily and fatty food? We refrigerate them. Alright. So we can either put it in decrease the temperature, put it in refrigerator so that it lasts a little bit longer. Alright. So second option is refrigeration. Refrigeration. Alright. What is the third option that we have? Alright. We all use in our day to day life. Alright. We put antioxidant. Alright. Antioxidant means the substance which prevents oxidation of any food. Alright. So generally for pickles or anything we use salts, lots of salts. Alright. So we can use antioxidant. Use antioxidant. oxidants. All right. So this is it for the previous year question. All right. Hope you have learned a lot. All right. So before going to the exam, all right, make sure that you revise the question. All right. And here we have some list of important reaction. You can take a screenshot. All right. That is frequently asked in each and every year. All right. So this is a examples of combination, endothermic, exothermic, decomposition, and displacement, double displacement, oxidation reduction, which is frequently asked. All right. So you can take a note of it. All right. And before watching the video, you please do one thing. All right. Pause the video. All right. And try to solve question on your own. That will give you a very good practice before going into the exam. All right. And sure, we will meet in the next series of the video. Thank you for watching.